In June of 1816, it snowed in New England. Not a frost, snow. Several inches of it, lying on the ground in the middle of June in Vermont and New Hampshire and upstate New York. Farmers went out and found their crops flattened and blackened. They replanted. In July, it froze again. They replanted again. In August, it froze a third time, and that was the end of it, because there was no longer enough season left for anything to ripen. Across the Atlantic, in the same months, it rained in Europe almost without stopping. Harvests rotted in the fields. Grain prices doubled, then doubled again. There were food riots in a dozen countries. People at the time had no idea why. They blamed sunspots, which had been noticed and were unusually visible. They blamed lightning rods. They blamed God. The actual cause had happened a year earlier, about 8,000 miles away, and almost nobody in Europe or America had even heard about it. In April 1815, a mountain in what is now Indonesia erupted. It is called Tambora, and it produced the largest volcanic eruption in recorded human history. The scale is difficult to convey, so here is one number. Before the eruption, the mountain was around 4,300 meters high. Afterwards, it was about 2,800. Roughly a mile and a half of mountain was simply removed and thrown into the sky. The explosion was heard over 1,600 miles away. On islands hundreds of miles distant, soldiers were sent out because the sound was mistaken for gunfire. The immediate death toll in the region was enormous, somewhere in the tens of thousands from the eruption itself and the resulting tsunamis, and tens of thousands more in the famine that followed when ash smothered the farmland. That alone would make it one of the worst natural disasters on record. But the part that reached the rest of the world was not the ash that fell. It was the part that went up and stayed up. Because a volcano of that size does not just throw out rock, it injects gas, particularly sulfur dioxide, high into the stratosphere. And once it is up there, above the weather, there is no rain to wash it out. The sulfur reacts and forms a fine haze of tiny droplets that spreads around the entire planet over the following months. And that haze does something very simple. It reflects sunlight back into space before it reaches the ground. Not much of it, a small percentage, but you do not need much. Global average temperatures drop by something like half a degree to a full degree. That sounds trivial. It is not, because an average is not what you experience. What you experience is a growing season shortened at both ends, and frosts arriving in months where frost does not belong. A crop does not care about an annual average. It cares about whether there is a freeze in June. And in 1816, in the wrong places, there was. So follow what that does. In New England, the corn failed almost entirely. Farmers who had planted 3 times had nothing to show for it, and their livestock had nothing to eat through the winter. Many of them simply left. There was a substantial wave of migration west out of northern New England in the years after 1816, toward Ohio and Indiana and beyond. People had already been moving west, but a failed year turns a consideration into a decision. In Europe, it was worse, because Europe had just spent over 20 years at war. The Napoleonic Wars had ended the year before. Grain stores were low, armies had been living off the land, and the systems for moving food around were still recovering. Then the harvest failed. Bread prices in some places tripled. There were riots and unrest across France, Switzerland, Britain, and the German states. Switzerland declared a national emergency. It is generally considered the last great subsistence crisis of the Western world. in the sense that it was the last time much of Europe faced widespread famine from crop failure alone. And then the consequences start getting strange in ways nobody could have predicted. Here is the first one. When crops fail, the animals that eat crops become expensive to keep, oats in particular. And a horse eats a great deal of oats. Across parts of Europe, horses were slaughtered because their owners could not feed them, and the cost of keeping one rose sharply. In Germany, an inventor had been working on the problem of transport, and in 1817, the year after the failed harvest, he demonstrated a two-wheel machine that a person sat on and pushed along with their feet. It had no pedals and no chain. Those came later, but it is generally regarded as the direct ancestor of the bicycle. The link to the horse shortage is argued about by historians, and it would be too neat to say the eruption caused the bicycle. But he was working on the problem of moving people without horses in the exact year when horses had become a serious problem, and the coincidence is at least worth noticing. Here is the second consequence, and this one is not disputed. In the summer of 1816, a small group of English writers were staying at a house on Lake Geneva. They had come for a holiday, and it rained constantly because of the same haze that was ruining harvests a few hundred miles away. They were stuck indoors for days. So one of them proposed that they each write a ghost story to pass the time. One of the party was an 18-year-old woman. What she wrote that summer became Frankenstein. Another member of the group wrote a fragment which was later developed into one of the first vampire stories in English, which sits somewhere at the root of everything that followed in that genre. So two of the foundational works of modern horror fiction came out of one wet holiday caused by a volcano on the other side of the world that none of the people in that room knew anything about. There is more. The strange skies that year were genuinely spectacular. Volcanic haze scattered light, and sunsets in 1816 were unusually vivid, with deep reds and yellows. Art historians have noted that certain landscape paintings from those years show unusually dramatic skies, and some have argued that the eruption is visible in the paintings of the period. That one is a reasonable hypothesis rather than a proven fact, but the skies were real, and people wrote about them. Now, here is what I think this story is actually about. Nobody in 1816 could connect any of it. A farmer in Vermont replanting for the third time had no way to know that a mountain he had never heard of had exploded in a place he could not have found on a map. A Swiss official declaring an emergency did not know either. The link between an eruption in 1815 and a failed harvest in 1816 was not properly established until the 20th century. It took ice cores, which preserve a layer of volcanic sulfate in the ice for the exact year, and tree rings, which record a bad growing season as a narrow band before anyone could line up the mountain and the summer. The people who lived through it experienced the effect without ever having access to the cause. And that is the thing worth sitting with. Not that a volcano can change the weather on the other side of the world, though it can, but that in 1816, the world was already one connected system, and nobody living in it could see that yet. The atmosphere had been carrying consequences between continents for as long as there had been an atmosphere. It simply took us another 100 years to notice.